Thank you, everybody, for joining. My name is Phil, and I help with Open Source in Pharma, the nonprofit that helps to put on R in Pharma, and the wonderful workshop today by Allison. Thank you so much, Allison, for helping. This is a second year. Last year, your workshop was fantastic, such great feedback, and we're looking very much forward to having a new workshop this year on JavaScript. A couple quick notes. First is please just be kind and respect everybody. We're going to record today's session, so we'll probably ask everybody to stay on mute unless Allison asks you to go off mute, then that's perfectly fine. But if you do have questions, please do use the Zoom chat. We're going to use that primarily for the communications back and forth. There is in the instructions that we sent across today, a website you can go to create an account so you can follow along with the examples. If you haven't done that yet, we'll send the link in the chat box so that you can do that. What else? We are planning to record today, so just keep that in mind. We also will post this to our YouTube channel. It takes us a couple months to get the edits and everything done, so it doesn't happen very quick, but hopefully sometime later, December, January timeframe, we'll post the workshops on the R in Pharma YouTube channel that I'll link to also in the chat. Lastly, we do credentials for the workshops. We do ask that you stick around for 75% of the workshop and work along with Allison to get that. Basically, when you exit the workshop, there will be a form that pops up and asks you if you want to get your credential. Feel free to fill that out. If for some reason you don't see that, please send an email to info@rinpharma.com, and we will make sure that you get added for the credential. And with that, I'm going to pass it over to Allison for the workshop today. So excited to include this session on JavaScript, such an important piece of the open source space. And with that, Allison, you want to go ahead and kick off your screen share, and we will do the session for today.
I'm Allison Horst. I'm a data scientist advocate at Observable. Observable is a company that creates a platform and tools for people to collaborate together, making data visualizations and notebooks and reports in the browser. And what I'm going to focus on today is Observable Plot, which is a really amazing tool. It's a JavaScript library for creating quick and interactive data visualizations in JavaScript. Welcome, everybody. We'll say we're starting now. Um, okay, so like I was saying, some of the folks here might have wanted to add JavaScript to their data science toolkit. A lot of folks that have started working in other languages actually add JavaScript to their toolkit so that they can start more easily creating interactive visualizations in the language that often makes that possible. And I really like this quote from Tanya Shapiro, who is someone many of you might know, who says, like, at some point, like when you're trying to make custom interactive visualization, it always comes back to JavaScript. And so if you've been working in these other languages, one thing that's really cool is we're starting to see integration between these languages in different places. For example, if you're a Quarto user, then you might have noticed that within Quarto, you can have like R code chunks or Python code chunks, but you can also add an OJS code chunk, which stands for Observable JavaScript. So you can actually add what you're going to learn today right in those OJS cells in a Quarto document. And then when you render it, you can actually see the output that is your JavaScript data visualization. And a lot of things that you might have been using under the hood, like Plotly, HighCharter, Giraffe, HTML widgets, oftentimes will have JavaScript under the hood. So it can be really powerful and empowering to add some JavaScript data visualization to your toolkit. And like I was saying, excuse me, in Quarto, there's support for observable JavaScript, which is only slightly different from vanilla JavaScript, just in a few ways that make it a little bit easier to get up and running in an observable notebook, which is what we're going to be working in later on. So what this workshop is going to focus on is Observable Plot. And Observable Plot is, like I was saying, to start a JavaScript library where you can create really quickly, fully customizable and web ready data visualizations. And it comes from the team that made D3. So if you have been curious about starting data visualization work in D3, Observable Plot is built on D3 by the team that built D3. It plays nicely with D3, but it provides, like we'll see, a little bit of a nicer entryway to get you up and running with charts a little bit more quickly. So why might you learn Observable Plot as your first JavaScript library? If we think about there, because there are other JavaScript libraries, D3 is one. D3 is a framework for creating highly bespoke data visualizations. But when you create something with D3, the reason that you can create these like completely customized visualizations is because you're building everything up from scratch, like from zero, which means you are building the axes and you're building the tick marks and you're building the scales and then you're building the marks and connecting them to your data. And that means that you have full control over every single step of creating your data visualization. But it also means that to create kind of even a basic bar chart, for example, you might have 40 lines of D3 code. And so the creators of D3 were, like Mike Bostock et al. Thought, well, there should be an option to add one layer of abstraction so that folks can get up and running a little bit quicker to create common data visualizations, but still maintain the potential for expressiveness and customization that they could if they were building it from scratch. And so that's where Plot came from. And what's really exciting about Observable Plot, hopefully, especially for folks who are on this call, is that Observable Plot employs a layered grammar of graphics. Hopefully, that's like music to folks' ears on this call. If not, it's okay. Inspired by libraries like Vega Lite, ggplot2, Wilkinson's grammar of graphics, and like the layered grammar of graphics from Hadley Wickham. And so it's built and inspired by these tools that use the grammar of graphics that allow us to build up charts layer by layer. So Plot, like ggplot2 and some of these other tools inspired by the grammar of graphics, rejects a chart typology in favor of mark scales and transforms, and can be readily extended in JavaScript. And we'll talk a little bit about what that looks like. But you can, for example, extend Observable Plot charts by adding animation using D3, for example, which is not something we'll do today. But since they really are built with the same thing under the hood, that extension is possible. So that's really exciting because if you as our users or other data visualization creators have been using the grammar of graphics or building charts layer by layer, then you actually know quite a bit that you need to know to start quickly creating data visualizations with Observable Plot. So let's talk about how these look side by side. Since this is the R in Pharma conference, I'm going to specifically focus on a comparison of R versus observable plot to create a visualization. But you could see how this aligns with other packages and libraries like Plot9, for example, or any other tools using the grammar of graphics. So let's take a quick look at some side-by-side comparisons, and then we are just going to jump right in. So what this is showing is a minimum viable comparison of a scatter plot made with ggplot, that's on the left, and observable plot, that's on the right. These are color-coded to show analogous bits of code in each of these different tools. So on the left, we have ggplot. We're initializing the plot. We specify the geometry, the geom point, and then we give it the data and the aesthetic mapping. So we're mapping the weight variable from everyone's favorite data set, cars, to the x-axis scale, and the horsepower variable to the y-axis scale. And really, with the exception of a few more braces, brackets, and parentheses, this is really similar in observable plot, where you really are doing the same thing. You're initializing a plot. That's the first thing. Just saying, like, heads up, I'm going to be making a data visualization. Whatever layers come next, I want you to build on that data visualization that I've initialized. Then you specify marks. So unlike some other tools where you pick an explicit chart type, when you are building charts with a grammar of graphics, you instead of specifying the explicit chart type, you actually say what geometric shape you're using to represent the data. So in this case, that geom point and plot dot dot, the dot mark in plot, those are creating a dot at these coordinates or the location for our data. So we're specifying marks, and then we have the data that's within the first argument within that mark. And then we have these variables that we're plotting, and we can extend this, and we'll see how we can add more channels so that we can not only just plot variables, but also map other aesthetics onto those variables, like the size of shapes. But side by side, hopefully you see that these things, sure, like the syntax might be a little bit different, but the overall pieces are truly the same for building a basic chart and observable plot. And just a few more comparisons before we jump into our interactive session where we're going to be doing, like, we're going to be just doing code along activities the rest of the day. But a few more comparisons between ggplot and observable plot. Just note that some of these options have the same name, like fill, updating the fill color in ggplot and observable plot. Those are both called fill. But there are some differences. For example, to update the size of a mark in ggplot, you use size, and in observable plot, you use R for radius. And in ggplot, to update opacity, you use alpha, and in observable plot, you use just opacity. But they are largely similar, and there is really awesome new documentation on observable plot that I'm also going to share. That we can then compare across the two pretty quickly. And I'll also share a notebook that directly compares examples in ggplot and in observable plot. So I think what I want to do now is just hop into some interactive activities. So I am going to, at great risk, stop sharing. I think, but actually, let's see what happens if I click on this. Do you now see a notebook, or do you still see my slides?
I see a notebook. Observable
Yes.
plot for fast, fun,
I'm,
interactive data
okay.
visualization.
I am not going to stop sharing then. I am going to keep sharing on, but I'm going to share a couple of links. So the first link that I'm going to share are some is a follow along notebook. So I'll put this in the chat. Okay. And that notebook, you are actually able to work directly in that notebook, even without an account, but none of your changes will be saved. So, I see a question here that I'll answer while I'm here. Is it possible to use observable plot in RStudio without Quarto? Um,
So
I am. Oh, sorry.
I was going to tell you, I think it went back to the Zoom page
Okay.
which is fine. Yeah, there you go. So
Is it back? Okay.
that's the notebook. There you go.
Cool. I'll stay here. I'm not sure in RStudio what that would look like, but I will say that observable plot itself is a standalone JavaScript library. So it doesn't necessarily have to be in Quarto, and it doesn't have to be in RStudio. Anywhere else that you can, load and then use JavaScript libraries, you can also use observable plot independent of working in an observable notebook or working in a Quarto document. So it's a totally standalone library for use elsewhere. Yeah, good question. All right. So I want to give folks a minute because what I am looking at is this notebook that we are all going to work in together. And there are two ways that you can follow along to work in this notebook. And the first is if you do not have an observable account, you can still follow along, but your changes will not be saved. So that's the first thing. If you do have an observable account, which you can sign up for free, so I'll give folks a minute or two if you want to sign up for free for an observable account at observablehq.com. You can sign up for a free account, And if you have a free account, then what you're going to want to do is make your own copy of this follow along notebook, because once you've made your own copy, then you are able to store the changes that you make today. I'll also be sharing, let me just go ahead and I'll drop this in the chat too. For anybody who just wants to maybe watch and follow along and get a taste for this, I just dropped the key. So you're able to see all the code that I'm going to be creating today. So again, I'll give folks a minute to either figure, like, see how you can work in Tinker mode, which you can expand cells in a notebook by clicking the little caret to the left of a cell, and then you can make edits. If you don't have an account and you make a change, you'll see a little banner show up after you execute the cells by pressing that play button or shift enter. And you'll see a little banner show up that says you are in Tinker mode. Your changes won't be saved. And that's completely fine for today. Just know if you're in Tinker mode and like you lose your internet connection or something, none of your changes will get saved. So heads up. Forking with an account is the way to go here if you're going to be following along. And just to reiterate again, and I'm going to do this too, if you have a free observable account, create your own copy, and I'll do this here. You're going to press this fork button in the upper right with the little forking branches coming off. Once you press that, you'll see you probably will only have one workspace that you can actually send this to, but I'm going to choose fork, and this takes me to my own copy where I can work. So those are the different ways that you can start working here. All right, I'm going to check the chat really fast. Okay. And you can use GitHub to log in. So there's a couple of different ways that you can log into your observable account. Yeah. All right. So if folks are still getting set up with an account or forking, that's fine. I'm going to give a lightning fast introduction to observable notebooks in case anyone hasn't used them before. Welcome. What we're looking at is an observable notebook with a bunch of pre-populated text and code and file attachments that we're going to be using today. You can see it's just in the browser. This is a web page that I could update permissions on and share with other people if I wanted to, so I can make this public. But this is just all in the browser. And you'll notice, like for those of you who have worked in other computational notebooks, whether that's Jupyter notebooks or our Markdown or in Quarto documents, that this structure will feel familiar. All of your content is in different cells, and those cells can be of different types. So for example, all of this text here is in Markdown cells. So you can see that there's Markdown formatting and then some text. So I can have Markdown cells, just writing Markdown like you would in our Markdown or in a Quarto document in cells. But we also can add other types of cells. So just as a demonstration of this and to kind of get people's feet wet with how a notebook works, we can add new content to a notebook by clicking this plus for an insert cell in the left margin of a notebook. So if I click that plus sign, that gets me to an add cell menu. And you can see there's a bunch of different options for cell types that you can add, or there are a bunch of code snippets. And we'll see those in a second. But for the sake of showing you kind of the fundamentals of how this works, if I just press enter here with JavaScript selected, you might not have been able to see my pop-up window there. I'm not quite sure if that'll show up in screen share. But if you click that plus sign and then, while JavaScript is selected, press enter, it'll insert a new JavaScript cell. And then I can say like x equals 2. And I can run this cell by pressing the play button in the right hand upper right of my cell, or I can do shift return, and that's the shortcut for executing that cell. And then this variable X now becomes available to me anywhere else in the document. And one thing that's kind of cool about working in Observable is that cells are run topologically, not chronologically, which means that you don't have to have your content in like linear top down order for the code to work, which I know feels unfamiliar for those of us who, have been working in like R scripts and R Markdown. But just to show you, since this will come up later, the way that we're using some attached files and stuff. If I insert a new JavaScript cell above where that x equals 2 is defined and say x plus 4, you can see that that runs just fine. So these recognize dependencies throughout the notebook and are able to execute the cells regardless of the order of cells in the notebook, which is pretty cool. Okay, so that's a really, really lightning fast introduction to observable notebooks. We put content in cells. We can add new cells by clicking on the plus sign anywhere in that left margin. And then we can either select the different cell types that we would want to add, or you can search for a code snippet, which is one of the first things that we're going to do. All right, I'm going to check for questions really quick. Cool. Hopefully folks are up and running, and I am going to head back to my notebook. Okay. Oh, I see a question here. Can you use this with Shiny? Great question. Not totally sure. Haven't tried it. Would love to. But one thing that you can do is you can embed any code that you have created in an observable notebook elsewhere. So I can show this later. You can select the cells that you would want to embed and then embed with iframe, or if you have like a React app. So sharing across different websites, for example, if you make interactive stuff here is pretty straightforward, which is a really nice feature. Let's go ahead and make our first data visualization with Observable Plot. Okay, so here's what we're gonna do first. I'm gonna introduce the data, and then for the rest of today, we're just gonna practice making examples. And while we're making examples, I'm gonna talk through some of the like fundamentals of working in Observable Plot, plus some tips and tricks and cool features that I think make it really fun to work with. We're gonna make some static charts first, and then very quickly, we are going to jump into creating interactive charts using observable inputs, which are awesome. Um, interactivity with observable inputs, I'll just say, was like a game changer for me after feeling like creating interactive visualization sometimes felt a little bit burdensome or cumbersome to me. Once I started learning observable plot and then added observable inputs to those, the quickness and like nimbleness with which I could create interactive visualizations felt really awesome. So what are we going to be creating a chart of first? So already attached to this notebook, and you'll see up in my notebook, I have this little file attachment pane that you can click on too. It's a little paperclip icon. You can see that there's already an attached usenergy.csv file. You can attach your own files here. If you click on that in your copy of the notebook, you can choose to attach more files. You can drag files onto your notebook and they'll automatically upload and attach. So we already have this file attached. And then later on in the appendix of the notebook, which I'm not going to scroll down to try to avoid making people dizzy, but in the appendix, you can see where I actually load that data into this notebook. So that CSV's data is already loaded. And I also in the appendix had created a subset of the data that only has the energy production for the United States for different types of energy produced for the year 2021. And then the amount is in quadrillion BTUs. And keep in mind, if you're like, well, where did this happen? That data import and wrangling happens at the bottom of my notebook in the appendix, but I can still use it up in the notebook because this notebook is running topologically and not chronologically. So let's go ahead and make our first chart. So you can see that this is tabular data in tidy format, where we have these three variables. We have the energy type, like coal, crude oil, geothermal energy, etc. We have the year. This has already been filtered to only 2021, so we're not going to include that as a variable. And we have the amount of energy produced for each of those energy types in 2021. So we're going to go ahead and start by making a bar chart of these different values and then sorting those from high to low. But instead of writing this from scratch, we are going to start with a code snippet and talk through this. You absolutely could write this from scratch in your own JavaScript cell, but we're going to choose a code snippet from the Add Cell menu just to get us started a little bit more quickly. What you'll also notice throughout this follow along notebook is that there's these show me buttons where if you expand by clicking the arrow to the left of show me, it'll show you the actual code that I'm going to be writing. There's a copy button that you could copy and paste into a JavaScript cell, and it also shows you the expected results. So you'll see those throughout the day. So hopefully that keeps anybody from getting stuck. Let's go ahead and start building this. So the way that I'm going to start building this observable plot chart is I'm going to click on this insert cell, the plus sign in the left margin. This can be between any two cells in your notebook, but I'll do it right below this let's start making a bar chart of values cell. And this is searchable. So what I'm going to search for is bar, and I'm going to choose the horizontal bar chart. So once you open the Add Cell menu, search for bar and then select the bar horizontal option. And what this does, which is pretty nice, is this creates a new JavaScript cell. So this is a JavaScript cell. This is JavaScript code, but it also pre-populates it with a code skeleton that actually works. So if you run this, again, by either pressing that blue play button to execute the cell or using the shortcut Shift Return, then you'll see that this is a functional bit of code using a built-in data set for letter frequency in the alphabet. And just talking through the different pieces again, just to remind ourselves that we're really building this using the grammar of graphics, we are initializing the plot with plot.plot. Then we specify our different marks, which in this case, we're using the plot bar X mark. So that's the geom in R is the bar X mark in observable plot. We tell it what data we're using. That's the first argument within our mark. Alphabet is a built-in data set in observable. That's why we didn't need to attach that anywhere. And plot is also part of observable standard library. So the library itself is also built in. And then after saying what the data is, we're specifying these aesthetic mappings. So we're saying the x-axis is where we have the letter frequency, y-axis is the categorical letter, and then there's also this extra option to actually sort the y based on x values, and then this just reverses it to get it from high to low. And all we need to do now that we have this snippet is let's go ahead and swap out some of this existing code with the data and variables that we want to actually visualize. So the data that we want to visualize is called Energy 2021. So that's the name of this subset that we're going to be plotting. So that's the data. And then what we're going to plot on our visualization is we're going to plot type as the y-axis categorical variables. And on the x-axis, we have this value for energy production, quadrillion BTUs. So those are the variables that we're going to update here. So I'm going to update this with energy 2021. On the x-axis, I have quadrillion BTUs. And on the y-axis, I have type. So here I have updated that code snippet. And now when I run this with Shift Return, now I can see that this is now updated with, instead of letter frequency from the alphabet data, is instead updated and sorted based on quadrillion BTU for the different type categories from this Energy 2021 subset. So that's a really, really quick way to get started. I really recommend using those snippets as you're getting started with Observable Plot. Um, just because what you like it's helpful to think about like the big elements of plot and not get stuck on braces, brackets, and parentheses. And starting from those code snippets still counts as writing code. And then you'll just update that with your own data and variables and any other options you want to customize. So let's go ahead and do just a little bit of customization here, and then I'm gonna pop back over and see if there's any questions. So what are a couple of things that we might want to change? So here we have this base plot, but a couple of things that you might notice are, for example, the types are cut off. So that left margin, the default left margin is a little bit too small. We might want to change the fill color of these bars. We might want to add grids, for example. So there's a bunch of different options that we might want to add. So I'm going to go ahead and just change a few things here. So first, just like in ggplot, you can, for your different geometries, you can add options for like a fill or a line color or a size. The same is true in observable plot. So within that mark where you're specifying the different options, I can, for example, outside of, notice that this is outside of that sort option, I'm going to say fill, and then instead of equals, you have a single colon, and then I'm going to give it a web recognized color like teal. And now I can see that my fill color is updated to teal for all of my bars. Then I'll also go ahead and outside of my marks, this is applying to my, not a specific mark. This is kind of a chart global option. I'm going to add an option margin left. And you can see as you start typing, you see all the different options that show up. I'm going to update margin left to 150 pixels. So now I can see that all of those types, we can see the entire name and we have this different color. But you can also have, just like you can in ggplot, sometimes we don't want an option to be set to a constant, like in this color, fill is set to a constant value of teal. Sometimes we want an option to be based on a variable value. And those, when you're working in observable plot, are referred to as channels in the documentation. So a channel is an option that changes based on a variable's value. So in this case, I can change fill to the name of a variable. Like if I change this to quadrillion BTU, now I can see that, now I see that this color scheme is showing up for these different values, and you can change the color schemes. So this is a built-in default, but you can also change the color schemes. There's built-in ones. For example, if I do color to change my color channel options, I can add scheme and reds. And now this is a light to darker red color scheme. Another thing that's really nice is, and for those of you working in ggplot, is organizing your plot code kind of vertically to avoid longer lines. There's a shortcut to do that in Observable, which is Option Shift F, and that will auto format your code to put it in that nice vertical format. So to talk through one more time what this example is doing, this plot.plot is initializing the plot. We have different marks. In this case, there's actually two marks. The plot bar X is where we're actually connecting this to our data. Our data is in Energy 2021. We map quadrillion BTU and type to the X and Y axis scales. There's a sort option, which you don't have to have, but this makes it nicely sorted. We've updated the fill channel to be based on that quadrillion BTU value. You can also see here, actually, there is a second mark, this plot rule X. If we take that out, then notice that actually is what creates that vertical axis. So a comment in JavaScript is 2 slashes. So I can comment that out, and then you see that vertical line at the y-axis removed. But if I uncomment it, then I see that line can show up. There's a bunch of other options for marks, frame, lines, transforms, pointers, cell, whatever. I mean, really, like, the options are kind of endless for the types of charts that you can create. And then outside of that mark section is where we can update kind of these global non-mark specific elements that are applied to the chart. All right, so hopefully folks were able to create, starting from a code snippet, your first chart in Observable Plot. Let me hop back to the chat really quick. Yes. So this is a good question. Let's see. So is there a way to bring up function documentation in the notebook? So those the shorthand TypeScript definitions that show up, that's the easiest way to kind of see the options. Otherwise, I would point to the observable plot documentation, which I'll also share here, which lists all the different options for observable plot. And this next question is a really good one. We changed the color scheme to reds, but in ggplot, this would be attached to fill rather than color. Can you help me understand this? How would we choose the stroke scale? This is a really good question. So there are, by default, different options are connected to different scales by default. So in this case, like if I do, well, let's just try this, stroke and then blue, then that is not being impacted. That constant isn't being impacted by the color channel because it's not actually a channel. It's just a constant. If I do quadrillion BTU, then those will both be updated, so we don't see those. But if I do, for example, year, then you can see that this starts not playing totally nicely together, because there are decisions being made about what option is being mapped to what scale, being mapped specifically to one color scale. But what you can do is, if you want to have full control over that, you can redefine what the scales are that different options are mapped to. So you can, in the plot documentation, if you look in the scales section, and I'll go to the observable plot documentation because it's awesome. And I'll put this in the link too. But you can see that within the scales section, there's a whole section that allows you to like set the scale for one channel to null so that you have control over what scale is being tied to your different options that you create. Let me go ahead and post this in the chat. All right. So back to our notebook. Hopefully folks are following along and we're able to create this chart. As a reminder, if for any reason you are not able to create this, you can expand that show me button immediately below where I just wrote that code, and that actually reveals the code that I created, and you can copy that into a JavaScript cell, and then that will create the visualization I just made. Okay. Let's add some interactivity. This is going to be great. Okay, because this is really where like I feel like observable plot shines, is like the expressiveness and quickness in creating web-ready visualizations in JavaScript. And then I think the ability to make it interactive just like really extends that. So let's go ahead and create some interactive visualizations. So for activity 2, what we're going to be doing is we're going to use a different mark. We're going to use a different subset of the data, and we're going to add interactivity to it. So this is going to be cool. So to describe this data set a little bit, this is only different in that this data set we're using is not filtered to only have data from 2021. So now we have the entire data set over all years that exist in this study, from 73 up to 2022. So we have an entire range of years. And what we're going to be doing is we're going to be creating first a static visualization of energy production over time for these different sources. Each source is going to have its own series. And then what we're going to do is we're going to add interactivity to that in a couple of different ways. we're going to do some that are like not super functionally useful, but just as proof of concept for how adding interactivity works. And then we're going to do one that I think is really functional. For example, if you have like a spaghetti plot and you have a bunch of series and you want to let a user highlight one of those series based on the name, for example. So this data set is stored as energy underscore production. So keep that in mind. That's the name of the data that we're going to be giving observable in this next line chart that we create. And our variable names are still the same. So we still have the energy type, named type, and we have the amount produced in quadrillion underscore BTUs. And then we still have this year variable, but now we have this range of years. So let's go ahead and first start by creating a static line chart. Again, there's the show me button in case you get lost at any point. That's going to show you the code that I'm creating to make this static line chart. So to do this, to add any content into a observable notebook, I'm going to add a new cell. So I go over, I click on my add cell menu, and I'm going to start typing line. And I'm going to choose the line option, just a plain old line that says values over time in connected lines. So, and notice again that once you select that line option, and just to say that again, in case that was quick, I'm going to go to the add cell menu by clicking the plus sign in the left margin. I'm going to search for line, and then I click on the choice for line, which is described as values over time in connected lines. And once I click that, then you see this new JavaScript cell inserted into the notebook, and you see that it's populated with some placeholder code to get us started. We could absolutely write this from scratch. You could write out plot.plot parentheses, curly brace, enter marks, colon, square brackets, plot.rule. You could type this all out when you start creating custom things or after you're more familiar with observable plot. That's great. But I think this is a good way to get started and build familiarity with the structure of plot code and let us create visualizations quickly. So here we're going to be replacing this. And if we run this, remember, these are functional bits of code using built-in data sets. So if I run this, either pressing that play button to execute or with shift return, you can see that this is a line chart showing the changes in Apple stock prices over some dates between 2013 and the middle of 2018. We don't want our line chart to be Apple stock prices. We want to visualize using lines the change in energy production over these different sources in the US over time. So the first thing I'm going to do is update my data. So I'm using the line Y mark, and I need to change from Apple to energy production. So I'm going to change that AAPL, the Apple stock abbreviation, to energy underscore production. You can also use tab completion here. So if you scroll when different options show up, then you can select and use tab complete. And on the x-axis, I'm going to have year, which is now a variable in that data set. And on the y-axis, I'm going to have quadrillion BTU. And I'm going to run this as is, and something not awesome is going to happen, which is something that those of you who have worked in ggplot2 for a while probably are like, yep, this feels very familiar. And what's happening here is we haven't given plot any reason, like it's only seeing the data and variables that we've provided it with, which means that it has no reason to think that there are actually different series in this data that should be their own group. So there's a couple ways to let plot know that things actually should identify as different series. One is you can add this Z option and then give it the name of the variable that you want to group things by. So this would be like saying what the group is in your ggplot code for a geometry. So now we can see that we don't have those weird lines, which is the code getting confused, or not confused, but just not having the information it needs to realize that these are different series. So that's one way that you can let it know what the different groups are. But the other thing that you can do is, like in ggplot, if you give it a channel that depends on this type variable, it'll also recognize that those are discrete series. So if instead of Z, and notice they're all the same color if I just use Z, if instead I use stroke, which is like Plot's version of color, if instead I use stroke, now I can see that each of these different series are individual and they each have their own color for the series. So really similar to how we would build ggplot charts. One thing to notice is that within ggplot, when you have options, if they are channels, meaning that they're options that are based on a variable value, that's within like AES, right, for an aesthetic mapping. Notice though that that's not the case here. Whether a channel is based on a variable or whether it's a constant, they all go in the same place, which is within those curly braces right after where you specify the data. So even, for example, if I was doing stroke orange, which is a constant, right, in ggplot, that would be outside of AES. But in observable plot, these are all just in this same section. And now you can see I have stroke orange, but now it does not differentiate the groups. And then I could say Z type. So just a heads up that whether it's mapping something to a constant value for an option or whether it's a channel, meaning that the value is based on a variable, they're all within the same area. You don't have these two like separate AES and then outside of AES regions. But I'm going to change this back to type for the stroke. Okay, so what are a couple of things that we are missing here? There's a lot. We're not going to go over all of them. This is, you know, in a quick workshop, is just a taste of observable plot to get people started. But one thing that you might want to add is, for example, a legend. And that legend, right, is based on the color scale. So the color for each of those lines is changing based on the type. So that's what our that's the scale that our legend is going to be based on. So here outside of marks, I'm going to have a comma. I'll press enter just for vertical organization. And I'm going to say for the color channel or for the color scale, excuse me, I'm going to set legend to true. And you can see that now we have a legend added. So that's how you can add a legend. I also want to show one really nice feature that is pretty recent and very exciting is that Observable Plot now has built-in tooltips. So this, as is, right, not an interactive chart. If I hover over any of the lines, I don't get information about the series. If I add, this is so cool. This is 8 characters to tooltips. If I add the option tip true within my plot options for that line mark, that's all that I need to add an interactive tooltip based on existing channels. So if I run this just with tip : true added, and then hover, now you can see that for any existing channels, in this case, type, year, and quadrillion BTU, you can see that now I have an interactive tooltip. You probably also, just because like I can never just look past this, that tick formatting on the x-axis, right? It doesn't know that it's a year, it just sees this as values. You also have full control over the formatting of your axis values. So here, this is on my X scale. I can update my tick format and I can update it to just have like capital Y to make year formatting. You can have nothing in there, and that then it'll show up without the comma. But you could also change like the digits or the notation that you see, so you can really control how those tick values are showing up. So now we've created our first technically interactive chart with observable plot. I'm going to check for questions really fast. Oh, good question. Is it possible to transform a variable in the data within the plot call? For example, year over 100, or is it done in a separate cell? Yeah, this is a great question. So you absolutely can. You're going to write it a little bit differently. So, and you're going to write a little bit of JavaScript. The way that you do that is with a little function. So I would say for Y, and I'll talk through this actually because we're gonna do an example of this later on. So this is a great question and lead into that. So for a little bit of JavaScript, I promise we're not doing that much of it outside of plot. To do that, you can write a little function using an arrow function. If you're not familiar with JavaScript, this is a basically shorthand way of writing a function. So this would be like function of parameter D, and then whatever is on the right-hand side is what's going to get returned. So the way that you access properties from arrays of objects, which is what energy production technically is. So in R, we think about data frames. In JavaScript, we think about arrays of objects. And the way that we access properties, which we can think of as columns in this data structure, but the way that we access properties is using dot notation or bracket notation. Here I can use dot notation to say quadrillion BTUs, and that's going to access just the original quadrillion BTUs value. But if I wanted to instead convert this to some other thing, I could just do that division here, and then you can see that the scale is changing. So you can absolutely do transforms and operations right within plot, but you will be writing like a little bit of JavaScript code, but it's not bad. Yeah, so that's a little example. Great question. Okay, all for the sake of this, change mine just back to the out of the box quadrillion BTUs. And now, oh, tip doesn't work in Quarto. Interesting. Thank you, though. I hadn't tried it in Quarto, so that's good to know. Okay, thanks for the heads up. Hopefully that'll be in there soon. Okay, so we have technically, right, with tip true, we have created an interactive chart with that one extra line. You can customize tips. We might, if we have time, do an example later. You can change like how the titles show up, the text. You can add channels that show up in the tip that currently aren't here. But let's also think about other ways that we might want to add interactivity. And that's what we're going to do next. So adding the tip true or a tip transform, like a pointer transform within observable plot is one way to add interactivity. But let's say, for example, in this case, maybe not totally overwhelming that we have each of these different sources, right? But maybe we have like 100 energy sources or 200 countries, for example. And we really want our users to be able to select one of those things and have that be highlighted within maybe our spaghetti chart of what we've created. So giving the user control over what they're able to see. So how can we do that in observable plot? This is way cool. We're going to use what are called observable inputs. And observable inputs are a lightweight user interface element, aka a widget, that we're going to create with one line of code starting from a snippet. And what these inputs are going to do is they're going to both create the widget for us that a user can interface with, but they also store the value of the user's selection so that it can be used later. So let's go ahead and try this out. So I'm actually going to get rid of my legend in this example. So I'm going to get rid of my legend, and now we don't know what things are unless we hover over them. But I am next going to go ahead and add a couple of different inputs that add interactivity in a different way. To get an idea for how these work, first, we're going to create an element that is not maybe functionally useful, but it does make clear what's happening. So just heads up, I'm not saying this would be a functionally relevant widget to add to your viz, but I think that this will clarify how inputs work. So I'm going to create a value slider input. So it's going to have a range of values along which a user can slide to select a value. And I'm going to connect that to the line width option. So that's what I'm going to do next. Which is a stroke width is what that option is called in plot. So right above this chart, I'm going to again click on that add cell menu option. So I'll click on the plus sign, and then I'm going to start typing in slider. So when you type in slider in the add cell menu. You should see a little icon that's like, oh, that's something I could slide along to choose different values. And when you click that, then it inserts again a JavaScript cell where you've chosen that add cell menu. It inserts a JavaScript cell, but now there's pre-populated code to make an input. Now let's just see what this is actually doing. So if I run this, so if I execute that code, then you can see that I have a functioning widget that I can change the values for. And what this is doing is really cool. Is this is using this built-in inputs range, but there's a bunch of inputs. We'll see radio buttons. There are also checkboxes and drop-down menus and text boxes and date selectors. So there's a bunch of built-in inputs. This one specifically was built to create this range slider. You can also make your own, which is really cool. And then this range, the first argument within that inputs.range, that's the range across which you want the values to span. So in this case, from 0 to 100. There's also a label, which here you can change this. Like maybe I'll change this to like line width, which is what we're going to update. And you can also change the step, and that's just the increment at which a user's selections will change. I'm going to change this to range from 0 to 100 to instead range between 1 and 10. And the other thing that I'm going to change is I'm going to change the name of this stored value to pick width. And here we can see a couple of changes. Again, I can execute that with shift return. But here I have changed this variable, this dynamic variable, to be called pick width. It's ranging from 1 to 10, and it has a new label called line width. You can also add a starter default value with a value option. So if I do value 2, then that's going to be the default value. When someone refreshes this page or when someone first clicks on this link, for example, that's going to be the default value. So what is this actually doing? This is created this widget that we can see, but it also stores the value of the current selection. So just to put a point on what this is doing, in a new JavaScript cell, if I then call pick width, then I can see that as I scroll across those values in that widget, that the value of pick width is also changing. So this is a dynamic, quickly created, stored value that I can call elsewhere. So let's go ahead and use this. Another thing you might be asking yourself is, do I have to actually see the code in my notebooks? No, the default is that cells are pinned in edit mode, meaning that the code is visible. But if you click on that blue thumbtack to the left of any of your cells, then you can see that you just see the output itself. In this case, our slider widget. So now we have this widget created, but it's not connected to anything. All I have to do is change one of my chart elements to depend on that value, which is called pick width. So here in my chart now, I'm going to go down and I'm going to add an option for stroke width. Again, this is where advisable, probably not, but I'm going to say this should depend on pick width, that variable that we've stored. Now I can see when I run that. So again, I'm setting this stroke width option to not a constant. I could set it to like 10, right? But instead I'm setting it to the pick width variable, which is dynamic. And then if I scroll back up, I would see that when I now slide along that slider, that this is an interactive chart with varying line width. So would you need this to happen to make a visualization more clear or compelling or engaging? Probably not, right? But I show this to highlight that adding interactivity with inputs to observable plot really is 2 steps. You create and customize the input. That's what creates the widget and stores the value based on the name you give it. That's the first step. Second step is say which element of your chart you want to be based on that input value. And that's the 2 steps. And then this is interactive. Then like if you share this web page with somebody, the interactivity is maintained. If you embed this elsewhere with both the widget and the chart, the interactivity is maintained. So it's a really, really quick way to get from a static chart, although we had tooltips, but to add additional types of interactivity to your visualizations. I'm going to check questions really fast. View of is required. Yeah. So if you in the, oh, this is actually a really good reminder. So thank you. In observable notebooks, you can see in my observable notebooks in the show me section for any inputs that I create, that view of, after you copy this code, add view of in front of it. That's what actually is making it like show up in your document and not just store the output. So it's adding view of is both like revealing the widget itself and it's capturing the current value at the same time. All right. So let's go ahead and now add something that is a little bit more useful. So I'm going to go ahead here and we're going to do a little bit of JavaScript, but I think it's in a fun way, and hopefully folks learn just like some fundamental JavaScript things that you'll see showing up in JavaScript visualization. So in addition to this line width variable, what if instead we also want a user to be able to select from a list of the different energy types, and whichever energy type they select in this radio button menu is going to be red, and whatever is not selected is going to show up as gray. So this is our goal, is that when a user selects an energy type, that's highlighted in red, everything else is in gray, so that they could really focus on just one type at a time. So I'm going to go ahead and create a new radio button input. So again, above my chart, I'm going to click on that plus sign to open my add cell menu. I'm going to start typing radio, and I'm going to select the radio input. And if I run this, again, these are functioning bits of code. You can see that there is a radio button created. There's only two options here, A and B. It's labeled select one, and the default starting value is A. But we don't want the choices to be A and B, right? We want the choices to be like coal, biomass energy, geothermal energy, natural gas dry. We want it to be all of the different options that show up in our energy production data should be listed in that widget. Now, what we could do is we could type those all out, but that's a little bit tedious. So let's write a little bit of code that actually does that for us. There are a number of ways that you could do this. I'm going to show you one. Like other languages in JavaScript, there's usually many different ways of writing code. I'm going to show you this one. So I'm going to first update this to, the name of this will be pick type. So that's the variable name that's going to get stored. So whatever a user selects, that is going to be stored as a variable pick type. So that's the first thing I'll do. And then instead of writing out this array of options manually, like instead of writing like coal, comma, natural gas, comma, biomass, which is one, tedious, and two, you're likely to make a mistake so that they don't line up anyway, we're just going to write a little bit of JavaScript code to access the type from each different object in our array. And then we're going to add an option to our input to only keep unique outcomes. So here, I'm going to show in a JavaScript cell what I'm doing first. So you don't have to do this, but just so you know what I'm doing. If I do energy underscore production dot map, map is a method in JavaScript that's going to iterate through each object in an array. In this case, those are like the rows in that table that we see. It's going to iterate through each of those, and it's going to return whatever you ask it to from a function within map. So in this case, that function is a little arrow function that just accesses the type property. So if I run this, then what I get, notice here, I get 479, an array of length 479. And that's because map goes through, in this case, map is going through every row. And for every row, it's returning the value of that type property. So we see biomass energy is repeated many times, like once for each year in the data set. Coal would be repeated multiple times for each year in the data set. But that's not what we want, right? We don't want radio buttons where biomass energy is repeated as many times as there are years. So we're going to add to our input an option that says unique true. So I'm going to add right after value, I'm going to add unique true. And what that's going to do is once we do give it an array, which we're going to use that same code that I wrote below, once I give it an array, it's only going to return unique values one time as radio buttons. So let's go ahead and do that. I'll write this out again, just in case anyone's following along and didn't write that before. So I'm going to say the array of values that I want to be included in this radio button are from energy underscore production dot map. So I'm saying I want you to iterate through each object in that array. And from each of those objects, I want you to access the type properties value. But because we've added that unique true, when we execute this, we see that they each only show up one time. So this is a nice little combination of using map to get all of the options, but all of these are duplicated. But then unique true just means that each of them will only show up once in our radio button widget. I also am going to make a couple of other changes. The big one here is instead of a default value of A, which is no longer relevant, I'm going to say maybe I want the default to be coal. And now I can see when I execute that coal is the default. And if I refreshed or if someone else opened this page, then coal would be the default selection. Okay. So now we have this widget created that is stored as pick type. And I'm going to check for questions. Okay, looks like we're good. Hopefully everybody's following along. Awesome. Okay, so now I have this new input where whatever is stored as a person's selection, the user selection, is stored in this variable named pick type. So just again, to put a point on this, if I call pick type in another JavaScript cell, then that value is automatically being updated as I switch between my different options, which means that now gives me a tool to be able to refer to pick type anywhere else to highlight things in this case. So let's go ahead and do it. So now what I'm going to do is in my plot code, I am going to have the stroke color change based on whether or not the type of energy source matches the user selection. So if the user selection matches the energy type in this data, then I want that line to be red. I want that series to be red. Otherwise, I want that line to be gray. So let's see what this looks like. So instead of just saying stroke type, we're going to learn another little JavaScript thing, which is called the ternary operator. I'm going to start by saying, here's a little function where I'm asking, does the type property value match the pick type value? So that's the first question that I'm asking. And if it does, then I want to have the line be red. Whoops. And if it doesn't, so this is asking, is that true? Then do this. And if it's not, then I want the line to be gray. Now notice here something weird happens, which is that it again is like, okay, I understand that this one series that does match pick type is its own group and that should be red, but you're not distinguishing between all of the other series. So that's where I'm going to add back this Z and then set Z to type so that each of those lines is still distinct. So to talk through this again, what this is doing in this step is I've created that pick type widget where a person selects the different energy source that they want to highlight. What this code is doing is it's saying, hey, does the type value match that pick type selection? If yes, so if that's true, this is the ternary operator, is this question mark and then colon notation. If that is true, return red for the stroke color. But if that is not true, then return gray, which is why here now we see that only a single series is showing up as red. And that's because coal is the only series where that matches the pick type option, is the pick type value. So if I then scroll up and I'll unpin this. If I scroll up and change these, then you can see that whatever I'm selecting is showing up in red and everything else is gray. So this gives me a tool where I can really highlight a different series that I'm interested in. And this was a lot, like maybe because it's the first time that we've written an arrow function in JavaScript or a ternary operator in JavaScript. But that's really powerful, right? Is that it's truly like to add the interactivity is really two steps. It's you create an input and customize it for your data, and then you link the output of that input to some element of your plot code. And in this case, we're writing that conditional statement using the ternary operator, where we're saying if the value for type matches whatever the user has selected, then I want that to be red. Otherwise, I want that to be gray. And we still have our tip that we can show on hover, but this is a nice way to highlight. All right. Any questions so far? Hopefully people are making some interactive views. Yeah. Good question. JavaScript is weird. I think we could say that about like many languages, right? Like they all have their little quirks and shorthand ways of writing things. You can absolutely in JavaScript write an if else statement instead. No problem. You can also write a function in standard function notation too, like function D curly braces and then what you want to return within the function body. You absolutely can do both of those. Both the arrow function operator and the ternary operator are just like ways to write things a little bit more concisely, but you do not have to use them. You can write these with standard function notation or with or with an if else statement. Okay, so now I want to move on. I think we're gonna do let's do a map. Let's make a map because everyone loves maps. Let's do it. All right. So we made this this visualization. Cool. But there's many other types of visualizations, right? But what I want to highlight in this last example that we'll do is that once you're familiar with the organization of plot code and the options available in plot code and how to link inputs with plot elements, it opens up a universe of interactivity and cool visualizations that are really quick right out of the box. So that's the next activity that we're going to do, is answer the question, where is energy being produced? So now we're going to answer a spatial question. This data is also from the U.S. Energy Information Administration from their U.S. Energy Atlas. And just as a little preview of the data, these data are also already stored. So these are already read in. They're stored as US_plants. This data set contains information about power plant location. So we have longitude and latitude. We have the plant name, city, county, other information. And we also have the plant's total capacity and primary source. And those are two things that we're going to use to create channels to really add to the richness of this map that we're going to be creating. I saw a question that I wanted to get back to about colors, I think. Is there a way to choose colors like scale color manual? Absolutely. So let me do some very dangerous live coding because I think this is a pretty common question. I'm just going to show this really quickly. So I'm going to create a new JavaScript cell. I'm going to create a scatter plot. So plot dot dot. I'm going to use the built-in penguins data set. On the x-axis, I'm going to have penguin flipper length in millimeters, and on the y-axis, I'm going to have body mass in grams. So this creates a scatter plot for 3 different penguin species. So I'm also going to have the fill color be based on penguin species. Now, if I want, and I'll just to put a point on this, I'm going to have color legend true. And you can see that this is for 3 different species of penguins, the relationship between how long their flippers are and how big their body mass is for Adelie penguins, chinstrap penguins, and Gentoo penguins. And what if you wanted a different custom color scheme? How do you change that color scale? And there's a bunch of different ways to do it. You can use one of the built-in color schemes, but you can also specify a new domain and range. So if I, for example, say, actually the domain for color, I want to be chinstrap, Gentoo, you could do this programmatically too, and Adelie. And then I want the range, which is our outputs, to be like red, yellow, green. Then you can see that you've now specified a new custom scale based on these different species mapped on to this new scale for colors. And you could do this like outside of this plot code too, and then call that in. So you can absolutely have a separate JavaScript cell where you create a color palette and then just specify, like if you named it my palette, here you would just have range : my palette, and then have that be the array stored elsewhere. So you absolutely can customize the scales for any of these channels that we're looking at. Great question. Okay, so back to our map. And one thing, domain and range, like the one thing that always, in case this is helpful, because I always get these mixed up. Domain is what is going in, like coming from the data. So that's going into the visualization. And range is what comes out, meaning that's like what we see in the visualization. And the only way that I remember this is that domain actually contains the word in. So otherwise I will confuse domain and range all the time. But I always remember domain is the data coming in, and that's because domain has in actually in the word. In case that's helpful. Other folks probably have other ways that they remember that, so feel free to share those in the chat if you do. Okay, so back to our map. So we have this data on US power plants, including like their total capacity in megawatts for energy production, the primary source, so whether it's natural gas or hydroelectric or oil or coal, and we have information about where it exists. Let's go ahead and make a map. Before we do that, I do want to highlight, remember how I said that observable cells run topologically, so order doesn't matter. And I had said previously, like, oh, also we had attached files and then loaded those in the appendix. That's also where I've imported some of this spatial data. So just to show you what that looks like, because I think it's pretty cool. I, for example, have imported spatial data on the states. So this has the polygon data about US states from another observable notebook. There are many ways to get your data into observable notebooks or to work between or iterate on observable notebooks. And importing is one way. So anytime you have a named cell in an observable notebook, you can import it into another notebook just using an import statement. So this is actually where this is importing the US state maps that we're going to create is from another existing notebook. So just to take some of the mystery out of where this spatial data is actually coming from, it's not coming from the ether. We actually have imported the spatial data from an existing notebook where we used it previously. So to make this map, what I'm going to do is I am going to, again, start with plot, but I am going to use plot geo to plot spatial information. And for those of you who have worked with spatial data, one thing that we're going to need to give this is a projection. Like, how are we taking information that is actually on an imperfect sphere, and how are we projecting that in 2D space to make our visualization? So we're going to have to give our plot that information about the projection, which this is also where I'm like, oh my goodness, this is so nice. Then we're going to use the plot geomark to actually add that spatial data. And then we're going to add another mark to add locations of these different power plants to make a bubble map. So that's the steps that we're going to follow. And I'm going to write this out by hand. There's not, in the add cell menu, there's not an observable plot like US states snippet. That's okay. This is all just in JavaScript. So I'm going to go to the add cell menu on the left, in the left margin. I'm going to choose JavaScript. That inserts a new JavaScript cell. And I'm just going to write this plot code out. So I'm going to say plot.plot. And this is a good reminder of what's actually happening in each step and how this maps onto the grammar of graphics. This just initializes the plot. This is like, hey, everybody, I'm making a plot. Get ready. So we initialize the plot, and then careful with braces, brackets, and parentheses here. So I'm going to add one set of regular parentheses immediately after plot. I'm going to add within that a set of curly braces, and then I'm going to press enter to give myself some space. So go ahead and press enter and see if I can get this thing to not cover the code. And now I'm ready to start adding information about the plot globally, about the marks that I want to add, and other options. So this is my starting point. But the first thing that I'm going to give this plot code is I'm going to tell it what projection to use. So here I'm going to say projection, and you can look at the observable plot documentation for the plot geomark and see the different built-in projections that exist, like Mercator and Azimuth, and here we're going to use Albers -USA to give us a nice projection just of the US. But there are many other built-in existing projections you can use. Now, if I run this, like I can run this code as is, and like technically the non-existent data is projected using the Albers US projection, but nothing shows up. There's this plot area because I initialized the plot. Technically, there's a projection, but we haven't added any marks. Like there's no geometric shapes that are getting shown here. So that's what we're going to do next. So I have a comma after that projection, and this is where I'm going to add my marks section. So here you have marks, colon, and then square brackets. And within these square brackets is where I define my marks and any options as constants or variable channels that I want to use to update it. And the first thing I want to do just to get started is just use the plot geomark to make a map of the US states. This amazes me every time that this can actually work. So I'm going to use the plot.geomark and just give it the states data. And just with that, we can see that we have a static map of the United States using that spatial data that we had imported from another notebook. So it's really quick, but this isn't what we want. We want to actually show the locations of power plants. But what we should get used to is it shouldn't always be a mystery what options exist based on what different marks we're using. Sure, some of them have special unique options, right? But not all of them. Like we should expect that based on the options that we know for bars or other marks, we should be able to update the look and feel of this plot geo layer. And we can. Like if I then give it options for example, I'm going to say fill, and then we can use either web recognized colors or you could use hexadecimal color codes. But if I use a light gray here, and then say the stroke is purple, which is probably not what I want to do, but we can see that yes, indeed, those options that we were familiar with from other mark types are also working predictably within plot geo. And this is what you want to start building, just like you would with ggplot, is that like even if you haven't used a specific mark before, you can start like having a good idea of what you're able to change for each different one. So here I'm actually going to change this. I'm going to change this to, I'll just say white for the fill, which is a default. And I'm actually going to change the stroke to that light gray. So I have this nice background, barely there map of the United States to give us some context for the next mark that we're going to be adding. Pretty quick to get to a map with a projection you want, right? I just love it. But we don't have what's really going to be like the main story of this visualization yet, which is the location and total capacity of different power plants by source in the US. So let's go ahead and add another mark. And this is where like specifying what you create by marks instead of explicit chart types is really useful, right? It gives you more flexibility because we're creating a bubble map, but the mark type that we're going to use is just going to be the dot mark. And then we're going to have the radius of those dots change based on the total capacity, which is what makes it a bubble map. So here I have a comma after my first mark, and then I'm going to have plot dot dot. But instead of pulling from states now I'm going to be pulling from that data set that I showed earlier, which is already imported and available for us. And that is stored as US plants. So now I'm going to say use US underscore plants. And then I need to give it the information about the variables from US plants that are going to be plotted in the X and Y direction. So here, the X direction, and this is one that also I always get mixed up. X is longitude, and that's the actual variable name, right? In this data set, we have a longitude and latitude property for our different objects. For Y, we have latitude. And let's just start there for now. So I'm going to start there. I'll scroll down so you can still see my code. But without doing anything else, now we have each of our US plant locations placed as dots onto our background map. And like ggplot, as you add layers, they get added on top of each other, right? So these dots are placed on top of that plot geo, which is why you can see them, even though that states actually has a white fill. These dots are overlaid on top of that. But we also want to update some other options. Like, for example, I want to first update the fill color to be that primary source variable. So here, that's called primary underscore source. So we're going to have fill be based on primary source. And I'm also going to update the radius of my points. So I'm going to have the radius be a channel that's based on total capacity. And here, when I run this, now I can see that I love this because it looks kind of like a Jackson Pollock, just like paint splatters, which I enjoy. That's probably not what we want to ultimately have, but at this point, I'm happy about it. But we can see that now not only do we have the locations of each of these different plants, but we also have them color-coded by primary source. That's what color is representing. And we also have the size indicative of or mapped to total capacity value. So larger circles here are plants that have a greater power capacity. But we can update this a number of ways. We can change our scales. So I'm gonna, again, I used to auto format that code. I used Option Shift F. So you can use Option Shift F, and that will automatically have that nice vertical code organization, which makes it a little bit more manageable to read and troubleshoot. And I, for example, can add here an opacity constant. So I'll say opacity is like 0.5, just like with ggplot. For the opacity option, 1 is the default, and that's completely opaque. 0 is completely transparent. And anything between that is on the linear scale of translucency for opacity. But I might also look at this and think like, well, some of these dots are super tiny and some of them are huge. Maybe I want to change something about that radius, about that size scale, which here is dependent on R. So this is another example. There was that great question earlier, like, can you customize the color scale? And so we saw that you can override a default color scale with your own domain and range. Like, what are the inputs from the data and what are the outputs that we actually see as the range? And the same thing is true for other channels. So let's try that again, updating a scale, but instead of for color, let's instead do that for that size channel, that R. So I, outside of my marks, so this is just applying to the scale for R, I'm going to say for my R channel, and then I'm going to give it what is the domain and what is the range. So what's going in and what do I want to be visibly coming out? So the domain is going to be the total extent, the total. I don't want to use range because that's going to confuse us with like range in terms of our visualization, our grammar. But that domain is going to be the extent of all values for plant total capacity, like what is from the minimum value to the maximum value. And we could like find that. We could do the domain and then find the minimum and put that here, and then the maximum and put it as the second element in an array. But instead, I'm going to use a D3 method, D3 extent. We think of D3 most often as a data visualization tool. There's also a bunch of built-in methods for working with data, finding summary values, grouping, and doing statistics. So D3 is really versatile, the different methods that are available. But here I'm going to say the domain, what's going in to this size channel, is the extent, which is going to get us the max and min from US plants. And then we give it again this little arrow function that says access the values in total capacity, in the total capacity property. When I run that, nothing changes. It still looks exactly the same, but this does give us a domain that goes from the minimum total capacity to the maximum total capacity in this data set. But what we want to do is we want to change the scale of size that those can be mapped onto. And to do that, that's when we're saying, okay, what is the output visual scale that we can see? So here we're going to say the range instead of the default. I want to be from, let's do something, I don't know, kind of weird. I'm going to say the range, I only want to be an array from 1 to 4. And then you can see everything is kind of small, but you can see this is a compressed scale for size now. So maybe I'll do 1 to 10. And then you can see that this is changing the size scale across which those total capacities are linearly by default mapped. So this is another example of how you can update a scale to override any of the defaults, is by giving it a domain with the inputs and then giving it a new range for the outputs that those are mapped onto. So as the last thing, let me check questions really quick. Yeah. So in Quarto, I'm not sure if it's updated. If you're working in Quarto, I'm not sure if PlotGeo is there. US plants is defined as an import later on in the notebook. So let me show you where that gets created. So US plants is created. I imported power plants from another notebook. So from that notebook, I import power plants. And then up in this data table cell, I just give it a new name, US plants. But it's imported from another notebook, which might be why you're also not seeing it if you're working in Quarto. All right, let's go ahead and make this thing interactive. So let's say again, let's say that, oh, we might want to just because I think this is interesting, let's go ahead and add a legend, because I think this is a nice data set where you can really see like things that make sense based on what we know about where things are. For example, we see along the West Coast in like the Sierra Nevada and Cascades, we see a lot of hydroelectric power in orange. We see wind, which is currently in pink. Again, we could make our own custom color scheme and map that to a new scale for color based on these different types. But we see a lot of pink, smaller circles in the wind belt, like in the Midwest, where we tend to get the most, the highest and most consistent winds. So that's where we have a lot of wind power. We see quite a bit of solar, for example, in California, Central Valley, also on the East Coast in purple, and then some other patches. So you can really start seeing like, oh, this kind of aligns with where we see power plants in the U.S. Based on environmental conditions. Let's go ahead though and make this interactive as our last step, similar to the way we added interactivity in that line chart. So once again, what we're going to do is we are going to create a radio button input where a user can select from these different sources for these power plants, these different energy sources. And then based on what they select, that is going to be highlighted in this map, and anything else is going to be in gray. So let's go ahead and try it out. I'm going to add a new input right above. So I'm going to, again, go to my add cell menu. I am going to search for radio. If you, by the way, if you look for inputs when you go to the add cell menu, if you instead type in input, you can see a whole list of inputs. Box tables, text areas, colors, file selectors. There's a whole bunch of options, and you can build your own. But I'm going to choose to create, again, a radio button. And here I'm going to have this input be called pick source. I don't think I've used that before. But now instead of only having selections for A and B, I want my selections to be the different energy sources that show up in that US plants data. So this is where I'm going to use a little bit of JavaScript again. I'm going to say, look at plants, US plants, map, which is going to iterate over each of the objects in that array. We can think of those look like my different rows in that preview we saw. And then I'm going to access from each of those, I'm going to access the primary source property. But what I want to do as a reminder, if I just run it like this, I'm going to get a huge radio button menu, right? Some of you might have executed this. It might take a minute to show up because that would create a different button for each individual property, even if it has duplicates. So instead, what I'm going to do here is I'm going to add unique, true, and then I can update my label if I want. I can have this be pick primary source. I'm going to change the default value to be, let's say, hydroelectric. And now when I run this, I have this nice widget that is both showing this user interface element that another person can interact with, but is also storing whatever value that a user has selected. So here, keep in mind, this is called pick source. Now we're again going to use this to customize our chart. So here, I'm going to do a couple things. I'm going to get rid of the legend because now we're just going to have this again highlight the user selection. And then I'm going to change something about the fill color, where here I'm going to change the fill color to be, again, use a ternary operator. So here I'm going to write a little function that is the same exact thing as writing like function of parameter D, and then within the function body is whatever you have on the right-hand side. So this is just going to say return D primary source. So the primary source property value, and ask, does that match the currently selected pick source value? So again, what this is doing is it's changing the fill color to ask the question, does the primary source match the current selection of pick source? And what's interesting here is you can see that the default is a false or true color scheme. And actually, I am going to add just to show you what's happening here. So if I add legend true here, you can see that false, those are the power plants that don't match the current selection. Those are by default given a light gray. And then anything that returns true for fill is given this darker gray. Those are the defaults. We're going to see how we can change these. So now, though, because we are able to see, because we've connected this to that fill, as we select different sources, we can see that they are highlighting just the selected source. But it's kind of hard to see because it's a light gray and a dark gray, right? It's not like a light gray and a red. So let's update this as a final thing so that it's a little bit clearer what these different, what our selection is. So I'm going to go ahead and I'm going to, instead of having a legend, I'm going to update the color range output. The input here is already true or false for fill. So I'm going to say, actually, I want the range to, instead of being from light gray to dark gray for true, for false and true, I want it to go from like gray to red. And now we can see that whatever is selected is showing up in red. I'll leave that code up there for a second. And the other things that we've learned so far are still true. Like, can I add an out-of-the-box tooltip even though it's a map? Absolutely. So I could add in here just tip true within that dot mark. And now I can see that that tip is showing up. And there are ways that you can customize how that looks, what shows up within the tip, but just adding out of the box interactivity with a tip true option is a really quick one to allow people to dig in a little bit more. So one more thing that I think is really, really nice is one thing that you might notice is that as we select these different selections, it's not automatically bringing the current selection to the front. Like some of these, although it's red, so you can see it pretty well. But like here, for example, let's try to find one where it's hard to see them. So I think coal is a good one. Maybe nuclear. Anyway, you can see in places here that the red is actually behind the gray, which can make it a little bit hard to see where some of those exist. But a really cool feature that I just learned about that I thought was so cool is that you can actually sort by channels. So here, if I want to sort by fill so that those true values are brought to the front, I can add a sort option and then say, I want to sort by what channel, and then I'll sort by fill. And then what that is going to do is this is sorting so that it's basing this based on these true values are coming to the front, false is in the back, because there's defaults about how things are layered. For example, with like a bubble map, things with smaller radiuses are brought to the front by default, for example. But this instead is sorting it by fill. So that we can see no matter what we click on, we don't have our selected things actually showing up behind the gray selections. And here we can really start seeing, like for wind, this concentration in the wind belt with our tooltips. For hydroelectric, we can really see that streak along the West Coast, up the Sierras and up through the Cascades, where there's a lot of hydroelectric, for example. And you can see our nuclear power plants around the state too. around the country too. So those are just a couple of examples for how we can add interactivity both quickly with a tooltip, which you could further customize, but also in 2 steps by creating an interactive input, which makes that nice widget that users can select from, and then by connecting that to some aspect of your visualization in Observable Plot. So I am going to stop sharing there and head back. And so we covered a lot today. We did like an intro to thinking about plot and where it fits into the grammar of graphics, just building layer by layer. We learned about how we can add different marks and include options that are either constants or create channels when those are connected to variables. We learned how we can connect those to inputs for interactivity or really quickly add interactive tooltips. We even did a little bit of JavaScript by using arrow functions and ternary operators to access different values of an array of objects, or to make if-else statements so that we could highlight what a user selects in a visualization. So that's where I am going to stop. There's a few minutes left for questions, but otherwise, thank you so much for joining. All these materials will be openly available. And if you haven't checked out the Observable Plot documentation, and especially the examples, I highly encourage you to, because any example that you see, you can also fork that notebook and then just replace your data and really get started quickly with really cool, interactive, interesting visualizations, and get up and running really fast. So thanks everybody for joining, and I'll stay on for a bit in case there are additional questions.
All right. Thank you, Allison, so much. Such an awesome workshop. One last note that I'll make real quick is that when you exit today's session, a form will pop up if you'd like to get the certificate for attending the session today. So if you see that, just make sure to fill it out. If not, you can always shoot an email to info@rnpharma.com and we can help you get that. So, all
Cool,
right.
thank you.
Any questions today? Yep, go ahead.
I actually missed the answer to my earlier question, which is that when we write the lambdas with the D argument, are those applied to the data set as a whole or to rows? Because when I tried to access, I'm used to R. I thought that perhaps the data set would be stored as a dictionary of columns, but then when I tried to do like dot a column name, that didn't work.
Okay, let me make sure I'm understanding correctly. So you mean when you write like an accessor function and do like D and then the arrow function and then like D dot something?
Exactly. Yeah. What goes into that accessor function?
Yeah. So each object of the array. So as each object, and that's like the row. And actually maybe I can
Okay.
switch over and show you, because we'll see if this works. But from each object of the array, and feel free to be like, no, I know that, and that's not what I'm asking. Each object has key value pairs. So
Yeah.
like instead of columns that are named, you have each object will have like type colon col, and
Yeah.
then comma. And so what it's doing is for each object in the array, it's saying, I want to pull out like the type value. And then that gets returned. That's part of the arrow function, is whatever on that is on that right-hand side is also returned back into an array.
Got it. Yeah, I think I was getting confused because in R, a data set is stored as like an object of arrays where each column has where each array is a column. Whereas here, I mean, in some ways it's more natural, but it seems like here it's basically being stored as an array of objects, each of which is sort of homogeneous. And that's okay. Yeah, I'm also getting confused by the argument.
Uh-oh, am I losing you?
I think we all lost him.
Oh no. Okay. I was like, is it me? Because it very well could be. But
Oh, he's
yeah,
back.
feel free. Okay. Yeah. And if you have follow-up questions, like feel free. I think it's sometimes helpful for me to look at the structure as an array of objects in my notebooks, which we didn't do today. I previewed them like in tables, but you can like call the name of any of those, just type like US plants in a JavaScript cell, and then you can actually expand the array view and see like each of the objects that it's going through and accessing that value.
Thank you. That's very helpful.
Cool. All right. I think that gets us to time.
All right. Well, thank you, everybody. And we have workshops all week. Feel free to sign up for the other ones. If not, we'll see you at the conference next week. Thank you, Allison. And with that, we'll go ahead and end the session. Thanks so much.
Thanks, everybody, for joining.
See ya.
Bye.
Bye.